All right, we started section 6.2 last time. In terms of the title, addition and subtraction of rational numbers, we've done the addition part. We're going to do the subtraction part today. And that puts us on this slide. So we're going to start with definition of subtraction. So if a over b and c over d are rational numbers, then if we subtract a over b minus c over d, this is the unique value e over f, such that a over b is equal to c over d plus e over f. And I'll give you just an example with whole numbers because it's easy to see why this is describing this. The reason that 5 minus 2 is equal to 3 is because 5 is equal to 2 plus 3. That's what that definition says. Right? The reason that the answer would be 3 is because 2 plus 3 would be the 5 I started with. It's the missing part. Theorem 6.8 talks about addition being equivalent to adding negatives. So if a over b and c over d are rational numbers, then a over b minus c over d is simply a over b plus negative c over d. Definitionally, I remember being in 7th grade and our teacher saying there's no such thing as subtraction. And she said it a lot. It's always adding a negative. What this is saying to you, is that subtraction is the same as adding a negative. Okay, so this is all turning subtraction into addition. And addition is what we did last time, right? We talked about addition of rational numbers. So what we're going to take now is we're going to take the things that we did with addition and apply them to subtraction. In particular, we have subtraction with like denominators, and we have subtraction with not like or unlike denominators. So if the denominators are the same, that's the first example, a over b and c over b, and we subtract them, then we just subtract the numerators, a minus c, and it's still over the same denominator b. And if you think about it in terms of that pizza that we talked about before, if you had, let's say, we'll draw our picture. We have our pizza, it's split into eighths. And we started out with 3/8 of a piece of pizza, right? 3/8 of a pizza. And then somebody ate one of them. Then you'd be left with 2/8 of a piece of pizza. So 3/8 minus 1/8 would be 2/8. That's your image. That's why it's still over 8. The size of the pizza didn't change. And then if you have unlike denominators, this definition again looks just like when we did it with addition. Visually speaking, we're multiplying a times d, and we're multiplying the b times c, and we're subtracting them. And then the denominator is b times d. This isn't the only way to do subtraction with unlike denominators, but it is a method that always works. So especially when you're starting out with small denominators that maybe don't have anything in common, right? Like a denominator is 3 and a denominator is 4. This is a good starting place for thinking about how we can get the denominators to be the same and be able to combine the numerators at the same time. Okay, so we're going to do an example. The example is going to have some mixed numbers in it, and it's going to involve subtraction. Martine bought 8 3/4 yards of fabric. She wants to make a skirt using 1 7/8 yards, pants using 2 3/8 yards, and a vest using 1 2/3 yards. How much fabric will be left over? So without talking about like the computational process, what is this question asking us to do? Subtraction, right? We're subtracting. And we're actually starting with what value? Yeah, 8 3/4. And then what are we going to do? Yeah, we're going to subtract off each of these things. So, if you can imagine, like she's laying all this fabric out and she cuts off the first piece, right? She removes or she subtracts it. So she's subtracting off, her first one is 1 7/8. And then she's got whatever that is left. There's a big old bolt of fabric still on the floor or on the table. And then she takes it and she subtracts off her 2 3/8. And then she cuts off again one more piece, which is the vest, and it's the 1 2/3. So this is the problem that we're working with. And I want to show you two different ways to do the particular problem, okay? Now we did a problem kind of like this. It just didn't have all the context last time. It looked like this right here, right? We had mixed numbers, and I showed you two approaches. One approach was to turn everything into improper fractions, and then to turn it back into mixed numbers at the end. The other approach was to leave it in terms of mixed numbers and combine the whole number pieces and combine the fractional pieces and then do the subtraction, okay? So, or the addition in this case, we're doing subtraction on ours. So those are the two processes that we're going to use. We're going to do a improper fraction approach, and we're going to do a mixed numbers approach. So I'm going to start with the improper fractions. So I'm going to take each of the values and I'm going to turn them into an improper number. So I have 4 on the bottom and 8. So remember last time we talked about this, we're going to multiply the 4 times the 8 and we add the 3. So 4 times 8 is, plus 3 is 35. So the first one is 35 over 4. The next one, if I do the same process, I'm going to do 1 times 8 plus 7. And what do I get? 15 over 8. So this is minus 15 over 8. Moving to the next one. 8 times 2 plus 3. 19. So I have minus 19 over 8. And the last one, I have 3 times 1 plus 2, which gives me 5 over 3. Is everybody good so far on changing all those mixed numbers into improper fractions? Okay, so the problem with all of these denominators is that they don't all match. Now the two in the middle do, so if you wanted to combine those to begin with, you could. That wouldn't hurt anything. But I'm just going to get them to all match. And because the numbers have nothing in common, actually the 4 and the 8 do, 8 and 3 don't, we might not want to simply multiply 4 times 8 times 3. The number will get kind of big, right? And it might just be overkill. So if you're looking at 4 and 8, what is the least value that they would have in common in terms of their multiples? They have a 2 that divides them, so they have a divisor of 2. Yeah, in terms of multiples. What would be the least common multiple between 4 and 8? Okay, between 4, 8, and 3 it would be 24. Just the 4 and the 8 would be 8, right? So I could change, just if you think about it one at a time, I could change this 35 over 4 into a denominator with 8, right? I could do that. But you're right, we can actually take a look at those, and we can look for the 8 and the 3, and we get a 24. So it would be nice to use 24 as the common denominator, which means the first one gets multiplied by 6, the middle one's by 3, and the last one by 8. And that will give me a 24 on the denominator of each of them. So the first one is going to be now a 24, and you might want to grab a calculator so you don't have to multiply it out by hand. What is 35 times 6? It's 210. All right, the next one has a denominator of 24 as well. The numerator, we have 15 times 3, 45. I have a denominator of 24, so now I have 19 times 3, 57. Like, this is kind of running into things. I'm going to shift it down a little bit. All right, and then the last one, I have the 24, and what's the numerator? 40. So all the denominators match, which means I can use the single denominator of 24, and I can combine all the numerators. So I can do 210 minus 45. Hang on. I think I missed something. What was the 19 times 3? Was it 57? I think it got deleted when I shifted. 57, and then minus 40. All right, so what is 210 minus 45 minus 57 minus 40? 68. 68 over 24 will reduce. What do they both divide by? At least 2. If we aren't sure any further, we could certainly at least start with 2. What is 68 divided by 2? 34. And how about 24 divided by 2? 12. Will they simplify again? Yeah, they're even again. So it divides by 2 again. 34 divided by 2. And 12 divided by 2, 6. And if you had noticed from the beginning, 68 and 24, you could have divided them by 4. That would have been fine. 17 over 6. Now that's actually the answer, except that it's not in the form I started with, right? We started with her talking about how many different yards she has in mixed number form. So we will put it back into mixed number form. And we talked about this last time. This means I take 17 divided by 6. How many times will 6 go into 17? 2 times. 2 times 6 is 12. We subtract to get 5. So my answer is the value that I divided out. That's the 2. The remainder, which is a 5, over the divisor, which is a 6. And we are working with a problem that has context, so we need units on the problem, which are yards. So I will have 2 5/6 of a yard left over. Okay, so a negative to this is that the numbers were a little bit big. I mean, you all used your calculator, which I'm not saying you shouldn't have. But if you didn't have the calculator or weren't allowed to or whatever to use it, like think about, the 6th grade student that's doing this problem or whatever, they might not really like this method very much for this problem just because the numbers were a little bit bigger, right? They had to do some multiplication, some subtraction, and so forth. So let me show you the mixed number approach. It has a negative as well, by the way. It's not all, roses either. But we'll use mixed numbers and see where it falls in terms of difficulty level. Okay, so with the mixed numbers, we have pieces that we join together that are whole number pieces, and then we put all the fractional pieces at the end. It's important as you look at this to realize that when I have the 8 and the 3/4, the 8 and the 3/4 are both positive. Whereas when I have the -1 and 7/8, the negative is on the 1 and there's a negative on 7/8. They're both pieces negative. Is everybody okay with that? So as I'm separating this, I've got the 8 at the beginning, and then I have minus the 1 from the 1 and 7/8, minus the 2 from the 2 and 3/8, and minus the 1 from the 1 and 2/3. And then I have the addition of 3/4, and then I have minus all the fractional pieces, so minus 7 over 8, minus 3 over 8, and minus 2 over 3. Okay, everybody okay with that? The first part's really nice, right? 8 minus 1 minus 2 minus 1, what do I get? It's 4. So the first part's 4. So it eliminates some of the size in getting these denominators now to match. I still will have the same denominator I had when I did it the other way. I still want the denominator of 24. So I'm still multiplying by 6, by 3, by 3, and by 8. So I still am going to get that 24 as my denominator. And I'm going to take a shortcut a little bit here because I know they're all going to have the same denominator. So I'm just going to put them all together at one time. 3 times 6 is 18. 7 times 3 is 21, and it's subtracted. 3 times 3, 9, also negative. And then 2 times 8, 16. The values at least are smaller than they were in the other one. So what do you get when you take 18 minus 21 minus 9 minus 16? Negative what? 28 over my 24. This is something we haven't seen before. Part of my answer is actually in a whole number part, and part of my answer is actually in a mixed or in an improper fraction part, right? We are going to have to make up for that. I mean, it's got to have to be one or the other. But before we do, it might be helpful to recognize that 28 and 24 both reduce. What do they reduce by? 4. So they'll both divide by 4. So I'm going to start here by dividing these by 4 before I worry about consolidating my two numbers. So I have the 4 at the beginning, and then I have negative 7 on top, and I have a 6 on bottom. Okay, everybody good? All right, negative 7 over 6. I'd like to turn that into a mixed number. What would that be in a mixed number form? 7 over 6. Yeah, so it will be 1 and 1/6 subtracted, or negative 1 and 1/6. So I have the positive 4, and then I have minus 1 and 1/6. I can do the 4 minus 1, right? You want to be careful. I don't want to just write down that makes it 3 and 1/6 because the 1 is negative and the 1/6 is negative. If it helps you, you can think about writing it like this. That's what the 1 and 1/6 being negative means. It means I have a negative whole 1 and a negative 1/6 1. So I'm running out of space. Let me make this a little bit smaller. So this is 3, but I still have minus 1/6. So I want you to pause for a moment and think about money, because money is a good reference point for all of us. 1/6 doesn't work well with money, so let's pretend like it's a 1/4, just for the sake of argument. I have $3, right? That's what it says, 3. And I owe you 1/4, hence I owe you a quarter. Okay, everybody good so far? Well, what would I need to do with my 3 $1 bills in order to pay you a quarter? Like literally, what would I have to do? I need to get change. I need to take one of my $1 bills and I'd have to turn it into quarters, right? And that's what I'd really have to do. We're doing the same thing here. We're going to take one of these ones. So instead of a 3, I'm going to have a 2. And I'm going to turn the other 1 that I'm changing into change into 6/6. It would be like me going and getting my 4 quarters that are equal to my dollar. 6/6 is equal to 1. And now I'm able to subtract the 1/6 from it. So I'm borrowing is what I'm really doing, or I'm exchanging, or I'm regrouping, all those words we've used at different points throughout sort of history of mathematics to talk about what's happening there. Now can I do 6/6 minus 1/6 pretty easily? Yeah, because now the denominators match. So I have the 2 that's at the beginning, and then I have the 6 minus the 1, giving me a 5/6, still in yards. That's not as easy as the first time when I used mixed numbers, and the reason is because I ended up having to do some regrouping in order to do the subtraction, right? And the reality is that over there with addition, let me bounce back over there for a moment. When we have, when we have addition, I likewise could have ended up right here, that 5/6 with it being top heavy. And if I had ended up with that being top heavy, I would have also had to change that into some kind of regrouping with the same kind of an idea. Okay, we have just a couple more things in this section. A couple more slides, I should say. Estimation is what we have. So estimation is the idea that sometimes exact answers are not really necessary to get the idea of what's going on. So fractions are, convenient fractions are fractions that are roughly equal to what we're given but easier to work with. These fractions would be examples of some convenient fractions. 0, not really in fractional form, but you know it's 0/1. 1/2, 1/3, 1/4, 1/5, 2/3, 3/4, the number 1, etc. Now when you get to your homeworks and your group work, what they're going to do is they're going to give you kind of almost like a multiple choice thing where they're going to say, which of these 4 values or 5 values or 6 values is the fraction close to? And you're going to have to examine it to make a decision. You're going to say, oh, look, it's about equal to 1/4, or it's about equal to 1/10 or something like that. Okay? It's going to give you some choices. Now, the ones that we're going to do, we're going to think of it sort of as a general statement of what other fraction is it equal to without those given choices. So we're going to take 12/78 and then 2/1001, and we're going to find an estimate to the following fraction, and then decide if our estimate is a high estimate or if our estimate is a low estimate. Like, well, how did we change it? Did we make it slightly bigger, therefore it's a higher value, or did we make it slightly smaller? All right, so if I look at 12/78, 12 is really close to what nicer number? 10. It just is, right? And 78 is really close to what nicer number? 80. And I like the 10 and the 80 because they divide quickly. And I can divide them both by 10 to give me a fraction that's what? 1/8. So finding an equivalent fraction is not necessarily the challenging portion of this one. But deciding maybe if the 1/8 is bigger or smaller than the 12/78 might be. So you have as a choice. If you want to, you could put both of those in your calculator and just see what the decimals kind of look to be, if you like decimal comparison a little bit better. I'd like to reason with you through why actually it is what it is. So if I take 12 and I turn it into 10, did the fraction get bigger or smaller? It got smaller, right? I created a smaller value. If I took 78 and I turned it into 80, just thinking about 78 and 80, did I make the number 78 a bigger number or a smaller number? I made it a bigger number, but I made it a bigger number in the denominator. And what happens when you divide by something that's bigger? Yeah, the whole fraction. So as I moved over here, the fraction is smaller because the denominator is bigger. So both the numerator becoming smaller and the denominator becoming bigger, making the fraction smaller, makes the fraction smaller than it was before. So this 1/8 is smaller than 12/78. So since it is smaller than 12/78, it is a low estimate. It is smaller or lower than the original value. And if you looked at it in your calculator, you would also have that sort of a perspective coming across from a decimal form. The decimal representation for 1/8, which is 0.125, would be smaller than the decimal representation you would get using 12/78.
Could you cross-multiply to check it too?
Sure, you definitely could. So like if you wanted to compare it, 12/78 with 1/8 and sort of questioning what it is between there, you could cross-multiply to verify that the value is smaller or bigger. You could do that too. Sure, it's another way. All right, 2/1001. First of all, that's a pretty small number, right? 2 is pretty small on top. 1001 is fairly large by comparison in the denominator. This number is pretty small. There are convenient numbers that we could use, and we don't even need to adjust the 2 on top. If I left the 2 the same, what could I, oops, I meant to put this to be approximation in between. What can I change 1001 to? That's pretty close to 1001, but it would work easier to divide. Yeah, 1000. So 2 divided by 1000 would be 1/500. So when I did this one, I only changed the denominator, and I made the denominator smaller. So if I made the denominator smaller, the denominator is smaller. What happens to the fraction? Right, the fraction would then become larger. So this estimate right here is a high estimate because it was larger than I started with. I only changed the denominator. Now that said, if this problem had occurred in one of the sections of your book where it said, pick one of these numbers, 1/500 is probably not one of the numbers that you have in your list of like 6 options or whatever. So you might still be looking for something different than this particular reduced ratio, but this would be one convenient, at least convenient-ish fraction that you have. If you looked, for example, at this list of numbers, which of these values in this list is the closest to 2/1001? 0. Yeah, 2/1001 or 1/500 is very small. It's nowhere near 1/2, right? It's very, very small. So the closest of these particular numbers, if this were our list that we were looking at, would actually be 0. It's almost nothing. Okay? Any questions on that? All right.